I'm Michael Anderson, Chief Editor of Battery Technology, and welcome to this Battery Technology Fast Chat. Today we are talking with Christopher Schultz, Director of Marketing for Hioki USA. Christopher, thank you for joining us today.
Michael, thanks for having me on.
Yeah, I'm so glad to have you here. So we're going to jump right into what we're going to talk about today. And I've got a few questions, and the first one is, what are the biggest challenges facing the battery industry today? Simple question.
Yeah, thanks, Michael. Thanks. Yeah, simple question. I think you would agree that lithium-ion battery technology is really good today. Right? Lithium-ion batteries are everywhere: cell phones, smartphones, smartwatches. Just looking at EVs, we have a decent supply chain. We have secondary, tertiary markets. We have captive and independent repair shops. We have got a decent charging network. So a lot of things are going well.
I suspect there's a however coming.
Yes, exactly.
Yeah.
Yeah, there's a lot of room for improvement, of course, right? The biggest challenge is the battery, the energy density. If we compare this to gasoline, we are still a factor of 100 away of having the same energy density. So energy per kilogram, energy per pound. That's not there yet. And we probably will never get there. And we don't, because a lot of the other things are more efficient than what internal combustion engines need. Charging time is another challenge, right? How long do we want to wait at a charging station? Safety. Safety is a big thing. Battery fires are all over the media when they happen. And cost. Cost is a big thing to get broad adoption in the EV space. And I would think the most difficult part really is to build a sustainable battery cycle.
Mm-hmm. Mm-hmm. Yeah. Those are all important. We're covering the thermal runaway worries pretty much every week here on our website. Right, but the big picture, as you say, is to get a system going where it's sustainable and it's going to work and it's getting better. So okay, so that will lead us to our next question, which is, at Hioki, from your perspective, how can test and measurement as a process help to accelerate the development of battery technologies?
Yeah, another very broad question. So let me think this. Let me put this way. I think there are 5 different types of applications that we have in battery from the test and measurement perspective. There's research and development, there's cell manufacturing, there's module and pack manufacturing assembly, there's the battery maintenance, and then there's the second life and recycling part. Right. So let me just pick one. Right? Let's say you're a researcher and you have an idea for a better battery chemistry. So you're a battery chemist. What you typically do, you build your slurry, you mix your chemicals, you build your slurry, coat an electrode sheets with the slurry, put it in a battery, wind it, fill the electrolyte, seal the cell, and then you can test the battery. Right? This is a very tedious and time-consuming process. And then finally kind of get results of if your idea worked or not. And if probably doesn't work the first time, you do it again. So one thing that we've been doing to help that research cycle is to build a tool that measures the electric properties of a slurry and the electric property or the electric sheet resistance of a electrode sheet. So with this, you can measure your slurry at an early stage and get a good idea of what the final battery would be looking like. So you can do all your design SKUs, you can do your different mixtures without building the whole battery. And even more, you can build battery models that can mathematically predict the performance of your battery before you build it. You can automate that and maximize the sweet spot where you think your best composition would be.
So you don't have to wait until the whole thing is done now. It's more like in process. you can check the various parts, the materials before they're actually put together. And so, yeah, okay. That makes a lot of sense.
That's exactly right. That's kind of how many other industries work, a semiconductor industry, right? So that's kind of a missing link that's being developed right now through testing. Right?
Mm-hmm. Mm-hmm.
And maybe you can give me another example. Right, like a production manager in an assembly line, let's say a module assembly line. Right. So you have hundreds, literally thousands of welds that you need to test. Each of the welds can be a cause of fire.
Right.
And even worse, right? So your assembly line, you buy battery cells from somewhere else. You cannot necessarily trust all the welds that you get into your factory. So each time you need to really test thousands and thousands of welds before to make sure your pack is safe. What we developed is a tool, a battery weld tester that is accurate, that's fast, and it's scalable. You can integrate that into an ATE, a flying probe ATE, and you can even measure welds before they cool down, so you get an accurate reading if your weld is good or bad. Before, and you don't need to wait until you cool the weld down.
Wow. Well, so it's interesting. So that definitely contributes to the eventual safety of the battery. So that was my next question: was how does testing and measuring contribute to making battery cells safe? And it sounds like that's one answer already, huh?
Yeah. Absolutely. Yeah, a lot of the things are about safety these days, about battery safety, and like you said, right, there's a whole community that tracks battery fires. I think there's some YouTube and Instagram, social media places where they catalog battery fires. And yeah, you don't want to be the manufacturer that's probably because of battery fires.
That's right.
So a lot of things you can do to prevent battery fires or reduce the chance of battery fires. There are two main reasons why batteries catch fire.
Uh-huh.
One is you have metal shavings in the battery cell, right? So your manufacturing process, you have various milling processes to build battery casings and the assembly materials. Metal shavings can make it into the slurry or into the electrode sheets or into the battery casing. So all of these shavings have potential to punch through a separator or to lead to microshorts, and that is very often the cause of a fire. So testing that is really critical.
Mm-hmm. Mm-hmm. So it's not only the cells, it's the packs too. Then not only the individual cells, but the packs, and then you have the entire unit. So it sounds like you have all of that. The testing can help prevent any of these types of mishaps. Yeah.
That's right. That's exactly right. And we continue innovating this technology. The problem on cells is very often, right? You have a hypo test that applies a high voltage, a few hundred to a few thousand volts on the battery and measures if you have good insulation. The challenge with that is that it burns off many of those microshorts. So the microshorts just evaporate. They're still there. The cell is still bad, but you can't measure that because you burned off the microshorts. So you flag cells that are good as bad.
Yeah.
And so our tester does have a microshort detection function that flags these microshorts and visualize and gives you a warning that you have a bad cell there.
Okay. Wow. Okay. No, this is very good stuff for people to know. I think that this brings me finally. Then let's go back to more broad, big topics. You mentioned the challenges. We talked a little bit about the challenges facing the industry, and so do you have any thoughts from your perspective about the future of battery technology and maybe about testing technology?
You know what? I went to Mexico City the other day. Mm-hmm. Beautiful city, amazing history, and a horrible traffic problem.
Yeah. And car exhaust. Yeah.
Oh, yeah. I mean, I imagine what would the city be like if we have more electric transportation? I don't New York, LA, Atlanta, Dallas, right? Less noise, less pollution, less exhaust, much more livable environment.
Yeah.
Batteries are an enabler for that, from my perspective. Right? We are in an industry that's in transition. We go from a hand assembly to industrial production. Similar process like many technologies went through. We'll have better materials. We will have better processing. We will. There's a lot of serious effort on recycling and reuse and building a circular economy around batteries.
Mm-hmm. Mm-hmm.
And I think
so. You're pretty.
Yeah.
Sorry. So you're pretty confident that this is coming. The electrification, it's happening. And so we will get to this the day where Atlanta and Dallas and Mexico City are cleaner and quieter. Huh?
Oh yes, absolutely. I mean, people will demand that, and it's happening right now.
Mm-hmm.
Right?
Mm-hmm.
Yeah, I think that test and measurement is a big part of that process, and we are privileged at Hioki to be at the forefront of that movement.
Absolutely. Well said. And on that note, I think that's kind of all the time we have for today. I've been speaking with Christopher Schultz, Director of Marketing for Hioki USA. And thank you very, very much for joining us and for this Battery Technology Fast Chat. And I look forward to talking to you again.
Thanks, Michael. Thanks for having me on.
Okay, great.